Alright, so for this question, it asks you to find the curvature K of the curve at point P. So first, you have to find the time at where the curve will actually at the point P. So if you set your I and j component equal to the point that they gave you, so 4t equal -4, and also 7t squared equals 7. So the t right here will be -1 for the I component right here, and this is the j. And then t squared will be 1, and then t will be plus or minus 1. But you can see over here that t will be -1, so over here should be also t equal -1. So now find the curvature K at t equal -1. Now you can use many equations. The equation I'm going to use right now is for this specific questions going to be the absolute value of x prime y double prime minus y prime x double prime over the x prime square plus y prime square, all raised to the power of 3/2. So first of all, I have the x equal 4 of t, the y equal to 7t squared. Now I'm gonna find x prime, gonna be 4, and then x double prime gonna be 0, and y prime will be 14t, and then y double prime will be 14. Now I have all the components. I'm just gonna plug it into the equations. It's very self-explanatory. So the k gonna be absolute value of x prime, which is 4 multiply for 14 double prime y double prime minus y prime, which is 14t multiply for 0, which is the x double prime. So this whole thing gonna be equal to 0. And then down here gonna be 16, because 4 squared plus 14t squared, all raised to the power of 3/2. And this whole thing, t will be at -1. So now you can plug in a -1 for t. So you would have k equal to top will be 4 multiplied 14 will get you 56, and the bottom will be 16 plus 196 3/2 raised to the power of 3/2. Now the answer you should get will be 7/53 root 53. Now this is your curvature. Now if they ask you to find the radius, r will be the opposite of curvature, so 1/k. So you would get 53 root 53 over 7. This is your radius.